these two people, and these guys here. See if you can see everyone. Can you appreciate it? Okay, yeah. Okay, thanks guys. Okay, I'll just set this right here and do it so everyone can hear. Okay, is everyone here familiar with Einstein's theory of relativity? I think we all kind of know that he developed it to explain space and time and how we perceive time. But what a lot of people don't know is that time is also widely accepted to be a dimension, as well as being relative. So that can be a little bit strange and not necessarily applicable to our universe. So how is this applicable directly to our universe? The answer to that question is through the concept of space-time. But what is important to remember that although space and time are both accepted to be concrete dimensions, it's also really important to remember that it's actually relative also. So to kind of begin to explain how time, is a dimension, but we can't really perceive it as being an extra dimension the way we perceive it in 3 dimensions, is to use the example of a 2D person. So a 2D person, you have to imagine that he lives in a world that's completely 2-dimensional. So although this note card has like a small width to it, he theoretically doesn't have any width and can't perceive the 3rd dimension at all. And so the only way he can move is left and right across the card. He has no capability to view a dimension outside larger than his world. So if I were to stick my finger into this note card, he would perceive only a small sliver of my finger and not the larger 3-dimensional object. So that's kind of how we can begin to wrap our minds around the fact that there is a dimension out there larger than our comfortable 3 dimensions that we cannot perceive. So one good question is that we do perceive time as being linear. So how is it possible that time is in fact a larger dimension, greater than the 3 dimensions that we're familiar with, but we perceive it as being linear? And there's a really great analogy, again, with this 2D person. So if this 2-dimensional person, if we fold his world into a dimension larger, a 3rd dimension, a 3-dimensional object here, he would perceive it. If he was moving from left to right across the card, he would be moving in a circle like this, in a dimension larger than what he can perceive. But what he views, the only thing he can do, is moving from left to right across the card. He's just moving linearly the entire time, while in fact he's actually moving around a larger dimension, around the 3rd dimension. And that's kind of how we can move. We perceive ourselves as moving linearly throughout time, the 4th dimension, while in fact time is a larger dimension outside of our comfortable 3 dimensions. Okay, so this is all a really good example, but it's not really applicable to our universe at all because we do not live in a 2D universe. We live where we can perceive 3 dimensions. And so how this is more applicable to us in our universe is through the concept of space-time, which addresses time as a dimension. And so a good example to kind of explain this is to look at space and time. So if you're moving along space as this first line, if you're moving along space along this first line, you could also move along another dimension, which is time. So this is space and this is time. So if you're moving through space, you can either turn and move through time, but then you're moving less through space. You're not doing the same amount of distance you would be if you were going solely through space and not moving through time. And so this can be applicable to, for instance, a lot of people have heard of the experiment where they take 2 elemental clocks that are perfectly synchronized, but one of the clocks on a jet, and they fly around the world really quickly. And when the jet lands again, almost imperceptibly, the elemental clock is a little bit slower than the clock that was on the jet. And so as the jet moves through space really, really quickly, it moves through time a little bit less. So we have to remember that space, that's a really great way of viewing time as a dimension. So we have to remember that moving through time as a dimension is also relative. And so a good way to think about that is that time is relative in a similar way that 3D objects can be relative for us. So if you're looking at a cubic meter object from the distance of 1 meter, it looks bigger than if you're looking at it from a further distance of, say, 5 meters. And so it is in fact relative. 3-dimensional objects are relative, which is kind of strange because we're all very familiar with the concept of 3D objects, but they are relative from person to person. And it's the same way time, although it is a concrete dimension, can also be relative. So now that we have a little bit of a further understanding about how time is a dimension and is in fact relative, we can take this understanding and kind of move it into the understanding of dimensions even larger, like the fifth, sixth, and seventh dimensions that are larger than time.